Okay, I would like to teach you about graphing quadratic functions in standard form, and before we get started I want to make sure that you have a pencil. So if you don't have a pencil, go ahead and stop the video, find yourself a pencil, because there may be some times here that you want to erase. And we want to make sure that when we're graphing we're being super neat. We only get one shot at it generally because there's one piece of graph paper given to us, so let's go ahead and use a pencil. So today our objective is to graph a quadratic equation in standard form that has a line of symmetry at x equals 0. And x equals 0 is the line that runs down the y-axis. So if you take a look here, if this is my line of symmetry, I have an equal amount of the graph, the x squared graph here, on the left as I do on the right. So we're going to be describing this graph a little bit, talking about its minimum point, which this one here is at 0, 0. It has its minimum value at 0, 0. And we are also going to be taking a look at what it means to be a parent function. So the parent function of the quadratic that we're going to be graphing is y equals x squared. And if you remember from Algebra 1, quadratic functions are those that have the form of y equals ax squared plus bx plus c. So we have an x squared term, we have an x term, and we have a term that has a constant and no variable. So can you think of any objects that may have a similar path to what the parabola has here? The parabola is the U-shaped curve. So an upside down U path, so the curve that we're going to be graphing could go this way if we have y equals negative x squared, or it could go this way when we have the parent function like we show here, y equals x squared. So what things in our world have some curve to them? Maybe you're a skateboarder and you know that there's skateboard parks that have places where you can skateboard on these shapes. Or if you've ever been to Cedar Point, you've seen roller coasters with these kind of things. So when we're planning major objects, we definitely want to know about quadratic functions and graphing quadratic functions. Please stop the video if you need to and copy down the vocabulary definitions here. So we have the standard form of a quadratic. It's any equation in the form y equals ax squared plus bx plus c. And I want to add to that a cannot equal 0. If a equals 0, then the first term there would be canceled because a times x would end up being 0, and then it would no longer be a quadratic. There wouldn't be a squared term. So we can't have a equals 0. Remember, a here is the coefficient in front of the x squared, b is a coefficient, and c is a constant. It does not have a variable with it. So a and b are both coefficients, and the constant term c is going to be added to it. Now we're going to go ahead and stick with, for this video, just the parent function and then comparing some graphs to the parent function. So y equals x squared is called a parent function. All of the other functions that we graphed today in this video are going to be called child functions. So they're kind of branches off of the parent function. They're slightly different from the parent function. So a child function has slightly different characteristics, sort of like you have slightly different characteristics from your parents. And we're going to be talking about those differences between the parent function of x squared and the child function that we'll be graphing in a couple of our examples. A parabola, as I already mentioned, is a U-shaped graph of a quadratic function. So again, if it's a positive x squared, it's going to look like this. If it's a negative, let's go ahead and write that, negative x squared, so it's like this, we're going to have one that's upside down. So that kind of gives it away that it's a negative quadratic function. And when we take a look at the axis of symmetry, it's a vertical line, and I mentioned this at the top of the paper there. It's a vertical line with the equation x equals a, okay, x equals a, such that it splits the parabola into two equal parts. So again, it's going to be the line that runs through the vertex, and it's going to be what splits the parabola into two kind of equal parts, although it's kind of an infinite thing here. It goes on and on and on, so it can't be exactly equal, but it divides it down the middle there. And the vertex is going to be the maximum or the minimum point. That's going to be our x and y on a parabola. So the maximum would be if it's a negative x squared, right? That's the highest point on this particular parabola or U-shaped curve. And the minimum point would be if it's a positive x squared. This bottom point right here is the lowest point that the curve goes. So we're talking about the vertex. It's like the top of the U or the bottom of the U. Well, I'm going to do 3 examples in this video, and then I'm going to ask you to finish your notes by doing the last problem on your own. So in this first one, we're going to be going ahead and graphing this function, which has a is 2. Okay, so our coefficient in front of the x squared is 2, and let's see how that changes our original or parent function. This is our parent function, x squared. Okay, notice that it has its vertex at 0, 0. And that it goes through, let's see, negative 2, 4, 2, 4, 3, 9, and negative 3, 9, and we also have, looks like negative 1, 1, and positive 1, 1. So those are just some points. We're going to go ahead and make a table of values. When you do your table of values, you want to pick some x values on the left side of 0. We want to pick 0, and then we want to pick a couple of points on the right of 0, or the right of the origin. So that's kind of where you always want to start with your x's. Always pick a couple negatives, 0, and then a couple positives. Sometimes you can spread them out just to see the difference, but I think this is a good set that we can always count on to start our table of values. So if we're plugging each x value into our child function, remember this is a child function because it's not exactly the same as our parent function x squared. It's slightly different because there's a coefficient of 2 in front. So looking at the x values, we're going to replace x in our function with each of our x values. So if I plug in a negative 2, I first have to square it. So negative 2 squared is 4 times 2 is 8. So each time I look at my x value, I'm plugging it into that function. Okay, so for negative 1, I'm going to take 2, which is my number in front of x squared. I'm going to square negative 1, which is 1, and times 2 is 2. When I plug 0 into 2x squared, I get 0. When I plug 1 in, 2 times 1, and we have to square the 1 first. Remember, exponents come first, so 1 squared is 1, times 2 is 2. And when I plug 2 in for that, so 2, and I have to square 2 first because that's a order of operations. 2 squared is 4 times 2 is 8. So now that I have an x and a y, I have actually 5 points here, don't I? I have this point, negative 2, 8. I have this point, negative 1, 2. And then I have 3 more points after that. So on my piece of graph paper, I can go over here and graph all 5 points. So from the origin, remember, this is our y-axis, this is our x-axis, so we have to go over to the left 2 and go up 8. So I have this point is my first point, I have negative 1, positive 2, and I have 0, 0, and then I have 1, 2, and I have 2, 8. Okay, so that was my first step. I did the table of values. I chose some values of x on both sides of the line of symmetry. I plotted those points. And now step 3 says to draw a smooth curve through the points. Okay, so as smoothly as you possibly can, I'd like you to connect the dots. And it should look like a U. Mine looks a little bit like a V. But you can see that if we have a smooth line here, it's going to be a shape of a U. Now, the fourth step is to compare the child graph, which we just did, with its parent graph. So this child graph here, why is it called a child's graph? Because it's not x squared. It's something other than x squared. X squared is the parent graph, okay, and this child graph is slightly different. What are the things that are different about it? So a couple of things. What things are similar? Let's answer that question first. One thing is we see the vertex is the same, and that means that the same bottom or the same minimum is at 0, 0. It's the same in the parent, the same in the child graph. Another thing that is the same is they both open upwards. So the graph itself opens up. Okay, the shape is a U, not an upside down U. And something that is different is that this graph, the child graph, is skinnier, right? The child graph is not as wide, we'll say it is more narrow than the parent graph. Notice that it's got less space in between the arms of the graph, right? It's not as wide as the parent graph where the arms are more open in the parent graph, so it's more narrow. Okay, so taking a look at example number 2, we're going to graph this function, which is another child function because it's not the x squared. So we have negative this time. What do you suppose is going to happen because we have a negative coefficient? The negative coefficient is going to result in an upside down shaped U, and let's take a look at how that happens. Now remember, you're going to choose, you can choose these, whichever numbers you like, but you definitely want to choose some values on both sides of the line of symmetry, which is x equals 0. Okay, x equals 0 is the y-axis. This is our line of symmetry. You want to choose some x values on the left, some x values on the right. So you definitely want to make some negatives in here. I always like to start with these. I think this makes it pretty easy, especially when we're comparing our graph to the parent function. So it may seem like I'm stopping my recording to fill in some things, and I am just to save some time on the video. So if things start jumping in the video, just feel free to stop and get what you need from the screen. Okay, so I've basically taken the time to plug in each of my x values, and the results that you see there are my y values. So now it's time for me to plot each of these ordered pairs. I have an x and a y, 5 different sets of x and y, and I'm going to go ahead and plot those now. Okay, so I've taken the time to plot my points on the graph, and I've also connected my points together, so now I have a U-shaped curve, and as we said, the curve is upside down, or it's an upside down U, because we had the negative in front of the coefficient. So a negative 3x squared is much different than its parent x squared. So what are the things that are the same? What are the things that are different? The same, we have the vertex is the same, right? The vertex is at 0, 0. There was the same point, 0, 0, that touches there even in the x squared function, right? So if I plotted the x squared function here, we would have something that looks sort of like this, right? If this is the parent function, what's different about the x squared function than the one that we graphed here, which is the negative 3x squared? Well, we said that the same thing is vertex is the same. Something that's different, of course, is that negative 3x squared, the child function, is upside down because of its negative sign in front. The child function is also much more narrow. So we'll just say that that is more narrow. It doesn't take up as much space on the graph paper. It's not as wide as the red parent function that I have above there. Okay, and before I move on to example number 3, I just want to make sure that you're being neat. Okay, so one of the key things about graphing is that you are neat. I know on this video it doesn't look super neat, but with your pencil and with your paper, try as best you can to make a smooth line when you're connecting your dots. And then the last thing I wanted to mention is that you should always add the arrows at the end of your graph, because this line, this curve, actually, it's not a line, is it? It's a curve, continues on infinitely at both ends. For our last example, we're also going to be taking a look at a child function. This child function has an added constant. Okay, so we're not just going to have a negative sign. Remember the last graph we did had a negative sign as well. We have a fraction this time for our coefficient, and then we also have a constant term, which is 3. So in this case, there is nothing that b, there's no b term, b is 0. So in terms of the quadratic, remember we said it's ax squared plus bx plus c. We just don't have this term in this particular function, but we do have an x squared term, which makes it a quadratic, and then we're going to add a constant of c. So let's go ahead and graph our function, and then we're going to compare it to the parent function, which we have shown right here, which we've been comparing to each time we've graphed something. So making up a table of values, I'm going to start with my standard 5, and then I'm going to plug those into my function and get my y values. Be really careful when you're doing this, because remember, you don't just have to plug in the value, but now we also have to add 3 to this. So we have a negative 1/2. I'm plugging in negative 2. I'm going to square that. Plus I have to add 3, because remember the child function here has a 3 added on. So once I square negative 2, I get 4. And I need to multiply that by negative 1/2, which is negative 2. Remember, you can use your calculator. Negative 2 plus 3 is positive 1. So be super careful when you're doing these. We're going to take our negative 1 now, plug it in here. And don't forget that you're going to add 3, because our function asks us to do that. So negative 1 squared is 1 times negative 1/2. So I'm at negative 1/2 plus 3. So negative 1/2 plus 3 is 2 1/2, or I could say 5/2. It's important that you're using a calculator, because these can be tricky. So let's go ahead to the next one. So when I plug 0 in, I have negative 1/2 times 0 squared plus 3. This just becomes 0, because 0 times any number is 0, plus 3. So I have a 3 now. And if I plug in 1, I'm going to square 1, and I get 1 times negative 1/2, which is negative 1/2, plus a 3. So I have another 5/2. And when I plug 2 in, negative 1/2 times 2, we have to square the 2, and that result is going to end up being 1. All right, so we've done our table. Now we just have to plot the points, and we have to draw our smooth curve through the points, and then finally we're going to compare this child function with its parent function and list some of the things that are different and list some of the things that are the same. So my child function is in purple on the graph now, and if I was to show you the curve of the parent function, remember, it's going to look more like this. Not quite that crooked, but anyways, it's going to have its vertex at 0, 0. Remember, the parent function starts at 0, 0. That's the minimum point. What's different about the purple curve or the child curve? Well, it looks to me like the child curve, or the child graph, one, that it's negative, right? It has an upside down U shape. And the child graph also has its vertex at not 0, 0, but at 0, 3. So the vertex is at 0, 3, right? The vertex meaning the highest point, or the vertex could also mean the lowest point. And obviously in the parent function, the lowest point is 0, 0. So it's also a little bit more wide than the original or parent function. So we could also say that child graph is wider. It's taking up more of our graph space. Okay, the last thing for you guys to do then is to make up your table of values for the new function that you have here. So we have this function. Notice that there's not a negative sign in front, so you should have a shape like this when you get finished, but you are adding 2, so be careful when you're doing your work that you remember to add the 2 at the end to get your y value, okay? Make sure you plot your points, draw a smooth curve, and then write a few things that are different. Is the child curve wider, more narrow? Does it have the vertex at the same spot? Those kind of things are the comparisons that you should be making. Please make sure you're neat and complete this last on your own problem for full credit.